Hello everyone, this is Mukesh. So today we will go through the basics of signal and the system. So here we will just go through the basic of signal system and mostly the signal part, not the system part. Uh, let's start. So when we see anything about the signal and system, there always involves some kind of input signal. Then there will be a system which will be operating on this input signal and then giving some meaningful output signal. Now when it comes to electrical signal, so in case of electricals, this signal will be in terms of the voltage and the current, and this signal will also be in terms of voltage and current. So in between there will be a system which will operate in this voltage or current and give us some voltage or current. Since this is an electrical system, so it will be made of some electrical component like resistor, MOSFET, capacitor and all. Okay, so let's take example of a very basic system. So let's see that this is a scenario that there is a voltage input and it is going through this. It is applied through to this series resistor R1 and R2, and we are taking the output voltage across this resistance R2, right? So if you apply some network, any network term like KCL or voltage division rule here, you will find that this voltage V out is nothing but this equation. So V out is nothing but this R2 upon R1 plus R2 into V in, right? So here our input signal is V in, which is operating on the system and giving it this output V out, right? So this signal is the input signal, this signal is the output signal, and the thing that you see here, that R1 and R2, this is nothing but a system. So this system is acting on this input and giving us this output. So this is a very basic example of a signal and a system. It can be very complex like amplifier, filters and all, but here just for the illustration purpose I have shown this example. Now let's go to the signal and its qualification. So when we say the signal, in general, signal can be a mechanical signal or electrical signal. So signal when terms inherently means that it has some information. It has some information related to some phenomena that has happened, something like that. So it conveys some information in terms of some quantity. So let's say there is a temperature that we are measuring, so that has some value and that will give some information about the temperature. So that's a kind of signal. Similarly, in case of electrical, the signal will be, let's say, in terms of voltage and the current, and the based on value of the voltage and current, it will give some value. It will give some information, right? Now, signal is a function of time, so it is generally represented as a xt or yt or ht, anything that is a function of time. Now, for example, here I've taken a signal which is not an electrical but a mechanical signal. So here this y-axis represent a dependent and x-axis represents a independent variable time. So this is the velocity which depends on this time, right? And there's a plot between this velocity with respect to the time. So this plot is looking like this. So here this plot is giving us some information about the velocity of the vehicle at the particular time t. In the case of electrical signal also, there will be some time axis, there will be some current or voltage axis which will be giving us information about the current or voltage at particular time. Now signal can be classified into the multiple ways like continuous and discrete time signal, analog, digital, complex and real, even and odd, periodic, aperiodic, energy and power, deterministic and random signal. Some of this a category like even and odd, complex and real, and periodic and aperiodic. This is similar to the function that we study in mathematics. So this will be very easy to understand. Now let's go to the continuous time and discrete time signal. So as the name suggests, this continuous time signal is the signal which is defined at all the time. It means that if I plot a signal, it will be continuous in time. There will be no break or there will be no gap here. Okay, so it will be continuous in time. Even if in this signal has some discontinuity, but it will have a value for all the value of time. Okay, so here when you, let's say, put t equal to zero point 0.3, so for t equal to zero point 0.3 you will definitely get some value here. Similarly, when let's say you put t equal to minus 1.5, for that value also you will get definitely you will get some value. Okay, now when you go to discrete time signal, in the case of discrete time signal, the signal is defined only a particular instance of time, some discrete instance of time, not all the value of time. So if you plot the signal, it will look like this, a discrete, in the sense that it is not defined in the middle, in between. So it is defined only at -4 and then at only at -3. There is no value of the signal at -3.5. Similarly, it is defined at 1 and then 2 then 0, but there is no value of the signal at x is equals to 1.5 or 1.3 or 1.2, something like that. So here the signal is defined only at the discrete instance, and generally in case of discrete time signal, this instance will be uniformly spaced. For example, here the spacing is 1, so this is 1, this distance is 1, this distance is 1, and so on. So the discrete time signal is generally uniformly spaced in case of electrical signal. Okay, so here when we say the continuous time signal, signal is defined at all the time. When we say the discrete time signal, this signal is defined only at the discrete set of time, discrete instant of time. Now when we go from continuous time to discrete time, uh, if you see in general in nature, whatever the signal that we see will be mostly in continuous time signal. So sometime when we go for electrical signal, we need to do some operation called signaling, sampling. So there we take the analog signal and then convert into the digital signal. So that is one way to get the digital signal from the analog signal. So let's say we have a continuous time signal xt and we want to get the discrete time signal xn. So what we do, we take this signal and the sample it. So based on the sampling time, we will get this signal. So let's say at t equal to 0, value of this xt was this. So I will take this sample, then t equal to some other value, let's say ts. We will get to this value. Then at 2 ts, we will get this value. Then 3 ts, we will get this value, and so on. So again, this will be uniformly spaced here. So this process is called the sampling. Later on, we will see more detail of the sampling. As of now, just take it as an understanding of how to generate the discrete time signal from the continuous time signal. Now let's go to the analog and digital signal. Now, before starting the analog and digital signal, there is always a doubt between among the student that this analog is signal is same as a continuous time signal and digital signal is same as a discrete time signal, but that's not the case. Analog signal can be continuous time and discrete time. Similarly, digital signal can also be a continuous time and discrete time. So let's see, when we say analog signal, so analog signal will be continuous in y-axis. So continuous time signal has a continuity in x-axis, that is in time, that is continuous time signal. But when we say analog signal, it doesn't care about the time. It can be discrete or analog continuous time, but y-axis has to be continuous, right? So it can take any value from minus infinity to infinity in y-axis, any value, let's say pi minus pi, 1 by 3, 1 by 4, minus 1 by 4, and so on. So y-axis can take any value, in y-axis, and but x-axis can be discrete or analog. When it comes to digital signal will take only a finite set of value in y-axis. So for example, this is the plot of one digital signal. It takes only two value, either 1 and -1, right? So here it is called a binary because it has only two array, only two value defined. By means two. So here only two values defined, 1 and -1. So here it can take some more value, but that number of amplitude that it can take has to be a finite set. Let's say four set. So for example, let's say four sets, so it can take value -1, 1, 3, and -3, something like that. Now, as I told, the analog signal can be discrete time and digital signal can be continuous time. Right. So here this will be discrete in time, but in y-axis it can take any value from -infinity to infinity. Here it will take only discrete set of values. So here again it is shown as an example with only two value, 1 and -1. Now let's go to the complex and real signal. So as the name suggests, the complex signal will take the complex value like e to power j at. So it is a complex number. So this signal xt is a complex signal. But in case of real signal, this xt will take a real value. So let's say a to power at, where a is a real number. So this signal is a real signal. It doesn't have any imaginary part. So this signal is a complex and this signal is a real. Now even and odd signal, so it is same as a even and odd function. A signal is called the even signal if it satisfies this criteria, that is x of minus t is same as a x of t. And for discrete time signal, x of minus n is same as x of n. Right. Now, since this is an even signal, it will be a symmetric respect with respect to y-axis or vertical axis. So when you plot any even signal, this will look like this. With respect to y-axis, it is a symmetric. So similarly, if you plot for the discrete time signal, this will also look symmetric with respect to y-axis. So if you put t equal to, let's say, 2, the same value will be for t equal to -2. Similarly, if you put t equal to a here, the value, let's say you are getting some value a here, the same value will be here for t equal to -a. In case of odd signal, this sign will get changed. So x of minus t will be minus of xt, and x of minus n will be minus x of n. Right. And now when you plot this, it will be just flipped. So in negative x, it will be just flipped of this, something like that. So let's say at t equal to a, you are getting some value. At t equal to minus a, it will be negative of this value. Right. Similarly, in the discrete time, when you are going to plot it, it will be something like this. So for positive value of t, let's say its value is positive. For negative value of t, it will be negative to corresponding positive value. For example, 1, n equal to 1, we are getting some value here. N equal to -1, it will be negative of this value. Now one more example is the sine. Sine is a odd function because it's a when you put t equal to minus t, it will be a minus sine omega t, but cos is a even signal. What happened? Okay. Now let's go to the periodic and aperiodic signal. In case of periodic signal, as a name suggests, it will be repeating itself after some average time is like some time instance. It will be repeating itself, and that repetition has to continue for all that value of t. It means that if repetition is there is a repetition, it has to continue till t equal to infinity and t equal to minus infinity. If it stops in between, it means that it is not a periodic signal. Okay. So for example, sine omega t is a periodic signal, cos omega t is a periodic signal. Okay. So if any signal which is a periodic, so here I have shown the example in with the help of graph. So here xt is a periodic signal. If you see here, it's repeating itself after t, then again at 2t, then at 3t, and it will continue till infinity. I have not shown it t equal to infinity as I cannot show it. It's like going till infinity, and this is limited space here. So similarly, it will continue till t equal to minus infinity and so on. So this is a periodic with t. Now if you see carefully, this is periodic with 2t also, because every after every 2t it will repeat itself. Similarly, it will be periodic with 3t. So in general, any signal which is periodic with t, we can say that it is periodic with 2t also, 3t also, and 4t also, right? So in general, this any signal which is a periodic with t naught can be written as like this, where m is an integer. So you can put any integer value, yeah. So it will repeat itself. Now there is a term called fundamental period. The fundamental period is the time period which is a minimum. So here we have multiple time period t, 2t, 3t. Out of the minimum is t. So that is the fundamental time period. So smallest value of t that satisfies this criteria is called the fundamental time period. Now similarly, just aperiodic signal will be just opposite of this. Aperiodic signal doesn't repeat itself. Okay. So now let's take an example. So this signal, if you see, this is repeating itself, and this repetition is continuing till it t equal to infinity and t equal to minus infinity. So if you see carefully, it is repeating itself after every t equal to 4, right? Here t equal to 4, then after 4 to it will repeat again itself at 8. So if you want to say what is the fundamental time period of the signal, it will be t equal to 4, right? Now for the discrete time signal, again this definition is similar as the continuous time signal. A signal is a periodic signal if it is going to repeat itself and it satisfies this criteria for all the value of n. Okay. Now again, any signal which satisfy this criteria for particular and not, it will satisfy this criteria for 2 and not 3 and not and 4 and not and so on. So therefore we can write this equation x m t and not is equals to xt, because where m is an integer. Okay. Now here again we have a concept called fundamental time period. So fundamental time period is a minimum value of time period. In case of aperiodic signal doesn't satisfy this criteria. Now, for example, let's say this is a signal which is repeating itself. So if you see carefully, this is repeating here, then here, and so on. So here it is repeating after n equal to 2. So here our time period will be fundamental time period will be capital N equal to 2. It will have time period 2, 4, 6, and 8 and so on, but its fundamental time period will be 2 because it's repeating itself after every n equal to 2. Right. Now, one thing to note is that in the case of continuous time signal, the time period can be any value, any positive value, any positive real value. For uh, for uh, for example, 3.2, let's say 3.2, let's say 1.5, and so on. But in case of discrete time signal, since n can take only integer value, this capital N will be only positive integer value. It can't take any uh, decimal value like 1.5 or 1.3, something like that. It will take only integer value. Now there is something called fundamental frequency, which is just the inverse of the time period, uh, and its unit is called hertz. And there is something called angular frequency, which is generally denoted as omega, which is 2 pi f and or 2 pi t, and its unit is radian per second. So you might have seen the sign sine omega t, where omega we can write it as a 2 pi f. So it's the same thing, where f is the frequency, and f is equal to 1 by t, and capital T is a time period. For discrete time signal, the angular frequency is given as omega equal to 2 pi by n, where capital N is a time period. Now let's go to the deterministic and random signal. So as the name suggests, the deterministic signal are those signal for which a signal is specified or any instant at any given instant of time. Okay. So here for example xt is equal to e to power minus t. Now since we know that signal is e to power minus t, we can know what will the value of xt at particular time is there. Just put the value of time and you will get the value here. Similarly sin omega t is also a deterministic signal, right? But in case of random signal can take any value, and we don't know what value it can take. It may have some probability, but we cannot say for sure. For example, here for when you put t equal to 1, x1 will be e to power minus 1. That is for sure. Its probability is 1. But here we don't know. Here it has different probability for different value, and since it here it's probabilistic, we don't know the value it can take. For example, let's say I'm plotting the xn, and xn is given as a 1 or minus 1. If its outcome is head, let's say we are tossing the coin. If its outcome is head, then it's 1, and if its outcome is tail, then it's minus 1. So here again you see here we it's not deterministic, it's random. For 50% of time it can be 1, 50% of time it can be minus 1. So when you plot xn, let's say I want to calculate the xn for n equal to 1 by tossing the coin. So I cannot say it will be definitely 1, because we don't know what will be the outcome of the tossing the coin. So that's why it's random. Another random signal is noise, that thermal noise, which come because of the random motion of the electron in the resistor. So that we will see more detail in the communication system. So in signal system we will not see this random signal again. It's only limited to just definition. Yeah, rest of the signal that we'll see in signal system will be deterministic. There will be no random signal. Now this is the let's go to the energy and power signal. So everyone know that when we apply a voltage across any resistor, some current will flow because of the Ohm law. Correct? Now, when the current is flowing through this resistor, we can say that this resistor is consuming some power. Now, this power is given as either V square by R, that is this, or I square into R. Right? So this power is the instantaneous power of this flowing through this resistor. Right? Now, if you put R equal to 1, then I can write as a P equal to I square T and V square T. Right? So if you see carefully, when you put R equal to 1, this I square T is same as a V square T. There is no constant involved now. Right? So both I square T and V square T are taking the same form. So if in general, if you see any signal in signal system, it will never be specified that its signal is a voltage signal or a current signal, and this current is flowing to this much ohm, or this voltage is applied across this much resistance. It will never be specified this kind. Or the only thing that is specified as just that signal has this expression. That's it. There is no specification of voltage or current. So that's the reason that in signal and system, the power is always given with respect to R equal to 1. So when we put R equal to 1, there is no difference between the current and voltage now. So xt, let's say I have given a signal xt equal to, let's say, some expression. It can be any voltage or current. To calculate the instantaneous power, I just need to square the xt. That's it. So in signal system, the power is always defined with respect to R equals to 1. Okay. So power is always given as x square t, where x can be a voltage or it can be a current. Right. Now, everyone know that there is a relationship between the energy and power. So power is given as the energy per unit of time, right? Or energy is nothing but power into time. So if you want to calculate the total energy, we need to integrate this PT to calculate the total power. So this is the power and this is the time that we are integrating it to calculate the total energy. Now, if you see here, we have put the mod here. This mod we have put because this xt can be a complex signal or a real signal. If it is a complex signal, you have to put mod. If it is a real signal, you can remove the mod and just square it. Now, to calculate the energy of any signal, you can apply it, say, this formula. So this formula is same as this formula where t is tending to infinity. So when you put t equal to infinity, this will become minus infinity to infinity. So that is this formula. So this is the way to calculate the signal energy of any signal. But this doesn't conclude that whether the signal is power or energy. This is just a way to calculate that signal has this much energy. Okay. Now we know that power is nothing but energy by time. So what we do, we take the energy and divide it by time. So this is the way to calculate the power. Now when you calculate the energy and power, so here the unit of energy is joule and the unit of power is watt, right? Now similarly for discrete time signal, the energy will be, instead of integration, it will be summation of the square, right? Because this is discrete. And similarly for for power, it will be summation of this term divided by time, which is nothing but, here this time is this minus this, that is this. Here this time is minus n to n. So number of sample from minus n to n will be 2n plus 1, including this one is coming because this n can take value 0. Now once, let's say if any signal xt is given, you calculated its energy. Okay, then you calculated its power, right? So when we calculate its energy, and if its energy is in this range, we conclude that the signal is energy signal. And if signal is not following this property, then signal is not an energy signal. Similarly for power, if power is less than infinity but greater than 0, then signal is a power signal, otherwise signal is not a power signal. Any signal which doesn't satisfy this two criteria is neither energy nor power signal, right? Now here signal can either be energy or the power signal. It can't be both energy or power signal. So take let's give you let's explain it. Why is that the case? So we know that the energy is given as is equals to p into t. So let's say that signal is a power signal, right? So it means that power will be some finite number less than infinity but greater than 0. So when I'm going to calculate energy, I will put power into time where time is tending to infinity. So this finite number multiplied by infinite will become infinite, right? So in that case it will not follow this property. That's why if signal is a power signal, it will not be energy signal. And similarly, p can be given as e by t, right? Now let's say signal is an energy signal. Since signal is energy signal, it will be less than infinity, greater than 0, so it will have some finite number. Now to calculate power, I will again put t tending to infinity, so this will become infinity. So finite number by infinity will become 0, right? So that's why the signal which is energy signal which has power equal to 0, and signal which is power signal that will have energy equal to infinite. That's why if signal is energy signal, it cannot be a power signal, and if signal is a power signal, it cannot be a energy signal, right? So if the signal is energy signal, its power will be 0, and if signal is a power signal, its energy will be infinite. Now there is one specific case for the power signal, and that is that if signal is a periodic signal, then definitely it will be a power signal. Okay, so since it is a power signal, our power calculation becomes very simple. So we don't have to put limit t tending to infinity here. we can just integrate this equation and we will get the power. Similarly, for discrete time signal, if signal is a power signal, a periodic signal, we can simply calculate the power by this formula. Now, here this capital T is nothing but a time period of the periodic signal, and here capital N is a time period of discrete time signal, periodic signal. Now, here this capital T is a periodic signal, so you can put the fundamental period, or 2 into fundamental period, 3 into fundamental period, and so on, because all of those will be the time period of the signal xt. Similarly, for n, you can put fundamental time period of 2 twice of fundamental or thrice of fundamental. Okay, now since this is a uh, here it's better to put the fundamental time period because that will make the calculation easier. Similarly, here put the fundamental time period, that will also make the calculation very simple. Okay, so that's it for the today's lecture. So we will be stopping here.